Welcome. Today we will be going through question 6 of the Maclaurin Olympiad 2020. Seth and Kane play a game. They take turns, and on each turn a player chooses a pair of integers from 1 to 50. One integer in the pair must be twice the other, and the players cannot choose any integers used previously. The first player who is unable to choose such a pair loses the game. If Seth starts, determine which player, if any, has a winning strategy. Please pause the video here and have a think about the problem on your own before proceeding to the hints and solutions. Hint number 1. Write out groups of doubles. So for example, 5, 10, 20, 40 make one group, and 17, 34 makes another group. Hint number 2. How many pairs are there? And can either side change the number of pairs depending on how they move? Hint number 3. Does Seth want an odd number or an even number of pairs? How about Kane? Solution. Look at the following sets: 1, 2, 4, 8, 16, 32, 3, 6, 12, 24, 48, 5, 10, 20, 40, 7, 14, 28, all the way to 25, 50. Each turn, Seth and Kane must choose two consecutive numbers from an arbitrary set. Now Seth will win if the total number of moves is odd, and Kane will win if the total number of moves is even. Apart from these three sets, exactly one pair will be made from each set, and there are 10 such sets, so 10 pairs. In set 3, 6, 12, 24, 48, no matter how Kane and Seth choose the numbers, 2 pairs will be made, and so that's 12 independent pairs which will be made no matter how Kane and Seth play. Now for Seth to win, he needs to make sure an odd number of pairs are made from 1, 2, 4, 8, 16, 32 and 5, 10, 20, 40. So before we think about this, let's think about something simpler. Consider 2 pairs of sets of length 4. Who will win? Well, the second player can copy the first player by playing whatever the first player plays in the other set. And so, thinking about it, the second player will always have a move, and so the first player will lose. So on Seth's first move, he can turn the set of length 6 into a set of length 4 by choosing the pair 1, 2, and it will be Kane's move. We also have 12 independent moves from the other sets, and because the number is even, they'll cancel out. It'll still be Kane's move to play in the sets. Now, Kane doesn't have to play in the sets of 4 first. He can play the independent moves, but so can Seth. And because there's an even number of independent moves, Kane will be the first to run out, and so he'll have to play in the sets of 4. And when he plays in the sets of length 4, he will be the first player to not have a move there. And if he's already used up the independent moves, he's lost. If he hasn't, he can play there, but Seth will always be the last person to have a move. And so Seth has a winning strategy. Thank you for watching. Please leave a like if you enjoyed this video, and feel free to drop a comment in the comments down below. Goodbye.